All right, hi everyone. Today we're going to talk about is rainwater runoff and floods. Now, I'm going to go kind of quick through some of this stuff. If you need to pause to write stuff down or rewind, please do. But I just want to try to make good use of your time. So make sure you take notes as you go through here and answer the different questions. So first thing, we're going to look at where water collects on the surface. So we have these things called drainage basins. And all that is, it's a place where water collects, right? So you may have a basin in your house. But it's separated from one basin to another by a thing that we call a divide. So divide just divides the space where like a roof water flows one way or the other. The same thing happens here. So you can have a large scale or a small scale. So divide is just dividing that one drainage basin from another. Okay, and all that water then flows down into your drainage basin. Here's your first question. So here's a map showing DuPage County. Wheaton North is located at that star there. To which river does our surface water flow, which is our drainage basin? Okay, correct answer there would be the West Branch River Basin, right? Because that's where we are. The blue lines are showing the dividing them. So all of our water will flow to the West Branch. Now, if you look at North America overall, right, we've got several drainage basins, and then the red lines are showing the divides, okay, of where the water in North America is going to flow. Now, Illinois, we're served by two of those drainage basins, the Mississippi Drainage Basin and the Atlantic Drainage Basin. Okay, so here you can see a map showing those basins colored, right? So the Mississippi is here in pink, and then the Atlantic is up here in green. So those are the two that serve Illinois. Now, for Illinois, where does most of the water in Illinois flow, according to this picture? Correct answer here is the Mississippi Drainage Basin. See, most of Illinois is in pink. And there's only this tiny little section, this pink area, right along Lake Michigan that drains to the Atlantic Ocean. And that's just because of the glaciers, right? They had all the moraines here. So if the water right by Lake Michigan will flow to Lake Michigan and eventually go to the Atlantic Ocean. Everything else is going to the Mississippi River and ultimately to the Gulf of Mexico. So now let's look at how at flooding and then how rivers change over time. So first, let's look at rivers, right? How they change. What a floodplain is, just a low-lying area that's by a stream that floods over time with large volumes of water, and they develop over time. So rivers don't get them to begin with; they grow over time, and you get these levees along the river that form from material being deposited, and then when you get further away, it's a little bit more swampy. So here's a picture, and I'll kind of take you through these that show this process. So this would be a young stream or a young river. So it's very narrow. It doesn't have much of a floodplain. Okay. Then over time, what happens is this river's flooded a few times. It's meandered along. It's flooded a few times, so you end up with a small floodplain. And then eventually, as the river gets older, it enlarges, right? So the river has had more time. It's meandered back and forth a lot more, just like we did with the stream table lab. And you get oxbow lakes, and that floodplain grows, right? Because this river, as it floods, it just kind of erodes material and flattens that area out to get the floodplain, okay? So look at the pictures here. When is the river the youngest, A, B, or C? Okay, correct answer here would be, I believe this was B down here, right? So down at the bottom here, it's young, so it's very narrow, no floodplain. Then you have some flooding happen, and then you end up with the floodplains occurring here. All right, so now next thing, let's look at urban rivers versus rural rivers. So first, we want to do definition, right? If you don't know what rural just means countryside, right? So with woods and trees and fields and forests. Urban, on the other hand, is characteristics of city, right, versus countryside. So buildings, concrete, blacktop. Okay, so question 4, is this a rural or urban? Of course, that is a rural environment, right? You got your farm there. Now, rural environments, as I mentioned, are mostly natural areas with fields and grasses and forests. Now, when it rains here, most of that water is getting absorbed into the ground, and it never makes its way to the river because it just gets sucked up by the ground. Okay, and if it does go to the river, it goes very slowly because it has to pass through rocks and leaves and soil and all that kind of stuff. So it takes, there's less water that makes it to the river, and it gets there more slowly, okay, as a result. Now, if we graph that information, we look at, here's time, and then here's river discharge, how much water is coming out of the river. After a rain event, it slowly fills the river, and you'll end up with a kind of a smaller amount of flooding here. because, again, most of the water is getting held by the land, and it doesn't get to the river quite as fast. All right, now let's move on to the next. Is this rural or urban? Of course, this is a urban environment. Urban, again, you've got lots of non-natural materials, roads, parking lots, buildings. Rain can't soak in because it's not going to soak into concrete or blacktop. It just flows to the sewer drain, right? And then it flows immediately to the river. So very little water is getting absorbed by the ground, okay? And the water is flowing very quickly to the river because it's going through pipes and roads and whatnot. So not very much is getting into the ground itself. So as a result, your river storm graph will look like this, right? So the water quickly goes to the river, and a lot of it goes to the river. Okay, so that's the difference between those two. So then that brings up this question: when we compare the two, which areas are more likely to flood? And the answer there is, of course, urban. Right? So because you have more water and it gets to the river more quickly, urban rivers and streams are more likely to flood than ones that are up in a rural environment. Okay? Now, how can we measure this? And why do we measure this? So it's important to study this stuff because flooding is so costly. Almost everyone in their lives at some point is going to be affected by flooding. So if you haven't already, you probably will at some point. And it's billions and billions of dollars. So you can see here since 2000, the taxpayers have paid approximately $850 billion to handle flood damage. So every year, businesses lose business, people's homes are damaged because of flood, due to natural disasters, flooding events with rivers or hurricanes, etc. And it doesn't take much. So 1 inch of water in your house can cost $25,000 damage to your home. And the reason that is because it's the removal of the water, it's the loss of all the stuff in your house, but also like this picture up top here, a lot of times you got to worry about mold and mildew and afterwards, right? So it can be very, very damaging. Now, so how do we try to mitigate this or make it not cost us quite as much? Is the USGS, the U.S. Geological Survey, monitors streams all over, okay? And we construct these graphs to try to predict how things are going to happen. Now, it's hard to predict for big floods because sometimes we just don't have enough data. So what we're going to do here is we're going to look at a river in Georgia, the Flint River, and we're going to look at some USGS data to see how we monitor streams and rivers, okay? Now, what the USGS does is they looked at, for example, the Flint River, and they do this for lots of rivers, is they monitor every year how high the river gets, and they record when it was the highest. And you can see here the highest this river in Georgia ever got was 290 feet above sea level, and that happened in 1994. That's the highest it ever was in 100 years. The lowest was 264. And now, if you take that, and they just kind of rank it out, and they see, well, how often do those floods happen? How often did it get that high? And you can see the highest one in 1994, it happened one time in 100 years. Okay, so it happens every 100 years. Compare that to 264 is the lowest. It gets that way every year. Okay, so that every year, okay, that's where it gets. And then you get this whole range going all the way between there. Now, from that, then, what we can do is look at probability. Well, if it happens 1 in 100 years, that's a 1% chance, right? Down at the bottom here, if it's a 1 in 1 chance, that's a 100% chance, right? It's going to happen every single year. So let's look at this chart and try to answer these questions. What's the probability of this river reaching 274 feet above sea level? Okay, what you should have said there was 1 in 2 chance, right? So 274 is here. You just have to look. Happens every 2 years. So there's any year it's a 1 in 2 chance or a 50-50 chance of that flooding to that level. Right? Now this one, notice that the recurrence interval of 5 years means that it's a 1 in 5 probability, which is a 20% chance. It's 1 divided by 5. Okay? So that's a 5-year flood. What's the percent chance of a 100-year flood? Okay, answer here should be a 1% chance. Because if it's 1 in 100, 1 divided by 100 is 1%. Okay, so every year there's a 1% chance of that flood happening. Okay, now let's make this local. If we have a 100-year flood here in Wheaton, what's the percent chance we'll have another 100-year flood next year? Okay, 1% chance. Okay, so and this is confusing. A lot of people think that, well, I had a 100-year flood last year, so there's no chance we'll have it again. No, that's not true. It's not a big chance, but there is a chance that you'll have it. It's a 1% chance. Okay, so then basically what we do is we take all those numbers and we graph them, right? So here's the flood frequency, the 1 in 1 year, the 10-year flood, the 100-year flood, the 1,000-year flood, and then this is the elevation above sea level, right? We're looking how high they are here. Notice that that's the flood frequency on the bottom. There's the how high the river gets along the side there. So a 10-year flood on the Flint River is the point at which that flood frequency, it crosses this line. So this is once every 10-year band right there. Okay. So with that information, use the graph to determine the 10-year flood. How high is the 10-year flood? About 280 feet, right? So that's all you do. 10 years is right there. How high is it? About 280 feet. Now that flood magnitude frequency graph can tell us the odds of your home flooding. You can say, how likely is it that your house is going to end up like these poor folks right here? So if your house is at 290 feet above sea level, use the graph to determine how often you should expect to get flooded. What is the probability? Okay, in this case, if you're at 290 feet above sea level, right, 290 feet above sea level, that's, you just go across here, and how often does that happen? Once every 100 years. So that's a 1 in 100 chance, a 1% chance your house is going to flood, okay, if your house is that high. Okay, so basically what this means is if you end up plotting this and you are above the line, chances are you're not going to flood, right? So if I'm 290 and every 10 years, right, 10 years, it's probably not going to flood, right? But if I'm below the line, let's say that I'm at 270 feet, right, and at 10 years, you're probably going to flood, right? So I'm below that line, so I'm probably within 10 years going to be flooding. Okay, so let's take a look. Another question here. You only plan on living at the house at 290 feet for the next 20 years. What is the likelihood of your house flooding sometime in the next 20 years? All right, so in this case, your house may flood, but the chances are it won't in 20 years, right? You're at 290 feet right here, okay, 290 feet. I'm right there. 20 years is, so there's 10, there's 100, so 20 is like about here. I'm above the line, so it may flood, right? But probably not, right? A 1 in 20 chance that you could flood. Okay. All right, everyone. So that's the end of that. Make sure you please stop in to see me if you have questions with anything, and have a great rest of your day. See you.